First Spin. Welcome to First Spin, a show where I learn how to use the parallax propeller without having any prior programming experience. Rather than do this on my own, I have enlisted the help of two experts.
Hello.
Howdy.
Hi.
I'm Whisker.
I'm Roy.
Yep. We got a Roy and a Whisker.
It's true. And an Addie. So, I was under the impression we would finish Unary Operators last week, but we clearly did not because bitwise not kind of threw me for a loop. So,
yeah.
But I figured it out.
At least we got through it.
Yes, it's true. So that was kind of cool. So we are almost. I think next week is gonna be the Parallax Expo, or is gonna be our trip to the Parallax Expo.
Yeah.
Huzzah!
So I think
this will be very exciting.
This will be the last episode that goes up before we're on the road.
Yeah.
And we're going to be recording some episodes live at the show.
Yes.
Yeah.
I don't know if those will go up while we're on the road, but you guys will definitely get to hear them all.
Yeah. So, and if you guys have any particular things you'd like us to touch on while we're there, do write in the comments, and then we can see what we can do.
I'd like some goulash while I'm there.
I don't think I can do that, Whisker.
Shoot.
We could probably find some at a restaurant someplace.
Oh, yeah.
It won't be as good as the goulash that Addie makes,
We could
though.
compare it. Maybe it's bitwise goulash.
Well, your kitchen will have, your room will have a little kitchen in it, so you could go to the store and get the ingredients.
I am not cooking on my vacation. That is not happening. That's a definite boolean not. Does that work?
Mm.
Well,
Can you say it like that?
Depends on how you use it. Like if you get the state wrong, you might be saying it's true.
That's horrible.
Yeah. if you're gonna boolean not it, then I definitely don't want any goulash.
Right.
Well, what if I boolean true it?
Well, you don't boolean true. True is a result.
Oh. Boolean yes. Not. Boolean not. Do they allow for double negatives?
That's just a double negative.
Right, so it's a positive.
No, it just depends on what you start with.
I think what you're looking for is an absolute
tangenting.
value, which we already covered.
We are just tangenting here.
Absolute value of goulash is awesome.
I give that a question mark. Random? All right. Let's continue and finish up Unary Operators with boolean not.
Okay.
What's that all about?
So, I think we've gone over Boolean stuff already, just the general
True versus false.
True versus false
Yeah.
and whatnot.
Yeah.
So, not is just saying whatever the thing returned, whether it be true or false, return the opposite of that.
Okay.
So, if you had...
So if you do boolean x or not x, it would take whatever x is and...
Depends on what x is equal to.
5.
Well, in the case of 5, it will be true because it's not false, because false is 0.
Oh.
And in the case of the Boolean not operator, it automatically promotes anything that's not 0 into true, which is -1. And then does the not operation on it, which will make it false. So if you say not 5, you get false.
Or and that's...
It's not mathematical not, it's Boolean not.
So anything that's not 0, it's going to turn it into a 0.
Right. It promotes, well, in this case, because it's not. So it doesn't turn it into a 0. It makes it the result of the Boolean comparison be
false.
0, which is false. Because it's just Boolean. So, like, you can only really use this in a situation where you're, say, doing an if, and you say, if y is greater than x, or you could say if not y is greater than x, would give you the opposite.
Huh?
right?
Okay.
So you could change that. You could. There's lots of ways to do the flip of that, right? You could do the not, or you could just say, well, if x is greater than or equal to y, instead of
Yeah.
y is less than x, right?
Yeah.
But this is just whatever if you have an expression, a Boolean expression, which is a comparison result usually, then that returns true or false, the not operator will flip it to the opposite.
So,
So if the thing that you tested against is true, if you prefix it with not in front of whatever the thing was, it'll make it return false instead.
okay. I'll take your word for it.
No, that's you need to understand, right? You're not supposed to just take my word for it.
Well, after last week's discussion.
Really, well, you're learning electronics, right? It's the same thing as
That's
an
true.
inverter in electronics.
Okay,
right?
so let's do how do you do an example of this?
Well, I kind of provided the example. Any non-zero is going to be turned into a 0, and any 0 is going to be turned into a -1. So it's
that's
fairly,
it. So it's just between 0 and -1?
Yeah, your -1 is true, your 0 is false. It's going to take any false and turn it into a true, and it's going to take any true and turn it into a false. And Roy said that any number that isn't 0 is going to be turned into -1 and then inverted.
Oh.
So essentially, any number is going to be turned into a 0 except 0, which is going to be turned into -1.
And I was just saying that because the manual says, promotes non-zero to -1.
Oh.
Right on the manual.
Oh.
That's what that means. So it makes anything that's not 0, and 0 is false. So if it's not 0, then it becomes true. And it converts it into the -1 for purposes of the result being a -1 when it's true. Like we explained before, that's because all the bits are on for -1.
And you can use this in more
I'm
than
flashbacks of last week with the not operator for Boolean, for non-Boolean.
Well, this is a lot more simple than that. But you can use this in places other than an if statement, right?
Yeah, but it's like I said, it's a situation where the thing that you apply not to is usually it's going to be treated as if it's a Boolean result.
So you could do something like x : equals not y.
X : equals not y.
Right, but all that's going to do is give you 0 or -1 depending on the value of y.
Mm-hmm.
So if y is 0, then it will give you 1 or -1.
-1.
And if y is anything else like 5, 10, 15, it will make it negative. It'll make it 0.
Right.
Because not that -1, well, what it becomes is 0.
Right.
And of course, we're using these as our true and false. So they're useful for comparisons between, truth statements.
Okay, I think I get it now.
And it just has to do with the case for Boolean operations in spin. True is -1 and false is 0. And so you can what Whisker's getting at is you can actually use that to your advantage in other mathematical ways besides with just truth tables for comparison, or if, while, and for loop.
I know Addie well enough to know that she likes to know how it works behind the scenes, and how it works behind the scenes is really, really simple. So
Okay. All right.
I wasn't suggesting that you should use it for doing math. You can, though.
Right. And you can use it for simple things like, assigning all the pins off or on based on a variable being something, right? So you could have a counter counting down, and while it's counting down, all the pins will be off, but as soon as it gets to 0, all the pins turn on. because you use the not
Ah,
operator on it,
I see. That's handy.
right?
That's handy.
Or
But-
the opposite of that.
But
whichever one.
usually you're going to see this as in an if statement. If not X, and then it does something, 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 right? Inside of the
Mhm.
if.
I don't know if I would use it.
You do when...
I think that I
you know,
get it. but
you've
it's just-
used if statements before, right?
Yeah,
Like
That's
if
easy.
this thing...
equals
But
this.
you're usually using them like if X is larger than such and such.
right.
This is just like if X, right? So
Yeah.
it's only going to do it when X is -1.
Yeah.
With throwing a not in front of it, it's only going to do it if X is 0.
Yeah. Well,
So
kind
I'll throw out another case where you might want to use it in a sort of more real example. Say you have a project you've done where you've got an LED that lights up whenever you push a button, and then it also causes it to play a beep
uh-huh.
when you're not pushing the button,
Okay.
right? So you could
Okay,
have
I see.
you can have an if the pin is on,
Yeah.
turn the LED on,
Yeah.
right? If the
If
pin is
not.
not on,
Yeah. I
play
see.
the sound.
So
I
it's
get it.
very easy to do something like if in a bracket 0 close bracket
Okay.
with a number in there.
Uh-huh.
Obviously, the 0 is your pin. So
Yeah.
you've
Right.
got if the pin 0 is on, do this. If it's not, do something else. By throwing a not in there, you can very easily invert it.
I see. Okay. All right. I get it. I might not use it immediately, but I get it.
It's one of those where it comes in handy every so often because you've got a set of conditions where you want the big side, right?
Mhm.
You want the side where all of your, things are going to get caught in it.
Mhm.
And the more efficient way to write it down sometimes is the inverted form.
Okay.
Mm-hmm.
I will accept it. Symbol address.
Oh,
This one's, so this one's probably not going to be used too often by you,
Okay. I know the only time I ever
but-
use it is like at stack.
right? And that's like one of the primary examples of its usage for people that are just doing spin.
Mm-hmm.
Is what it is it's the address of the thing, your name, your named variable or a label that you put in a dat section.
Mm-hmm.
And it's important to have addresses like this for when you're programming so that you can tell something where something's at.
can we
Sure.
just call this what it is? Do we have to call it a symbol address?
What? What is it?
It's a pointer,
It's a pointer.
It's a pointer.
Yep.
So let's call it
Right.
a pointer.
Okay, pointer.
but it's an operator that gives you the pointer given
Yeah.
a variable that isn't a pointer.
Right.
And you
I get it. I get that.
you could store that pointer in another variable and blah blah blah.
I get it.
Right.
Do stuff to it, do offsets into it, all sorts of crazy stuff.
It's like
So-
it's like when you have like a stack of papers and you want someone to sign here and you have that little sticky tab that you put there. That's like a pointer.
Right? But it's a number, so you could do pointer plus something.
Yeah.
It's
So I
really
want you to
more
sign
like-
on page 6
yeah, these are
plus
the page
3,
numbers.
Right.
right?
Yep.
What it's more like is not the little tab, but it's actually the page number that little tab is on.
Yeah, I like
Oh,
the
I
it's the address that it starts at, that variable starts at,
Yeah.
but you've
Right.
got a whole bunch of other stuff stored in addresses too.
Right.
So
Well, what does that remind me of? There's something that I was misaddressing and I ended up getting like a letter down the way.
yeah, you
What
had
was
some
that?
really strange bug a while back when you were doing some code where it wanted a pointer and you were handing it the contents of a variable, which threw it to a random place in memory.
Right.
But
Right.
it was doing the same thing every time, so it was giving you a bug that was kind of what you wanted, but not
But not
exactly what
fully.
you wanted, because it was jumping into memory at the same place, and the same thing was at that spot in memory,
Right.
and it was very close to what you were expecting. It was
Right.
just total like happenstance that it happened to get you that close. So it took you were frustrated with that and banging your head against it for days and days. And I took a 5-minute look at it and I was like, you are very silly.
What was
you are using user input to pick a memory address that you're going to start reading a string out of.
Yeah, that was.
It's just not what she wanted. But
I wish I remembered what it was, but it was.
Well, I know what it
silly.
was, but we're not allowed to talk about it yet because it's.
Oh, I see.
Yeah.
Okay, all right.
Okay.
I won't
So-
say anything.
Just to do a quick rehash there. So like the at stack thing that you were talking about earlier.
Yep.
The
It points
reason,
to the location in dat, right?
well, no. In this case, you had a variable that was a stack that was an array, right?
Yeah.
And when you pass at stack into the cog init or cog new
Mm-hmm.
function, what you're doing is you're passing the address of the beginning of that array of longs
Yep.
that the stack was.
Yep.
And it needs that so that it can use that memory
Space.
to hold the stack.
Right.
And similarly, the other example is with the strings in a dat section, right? You can type in, a label, byte, and then some string you want in a dat section, and then you can pass the address of that symbol
Mhm.
into PST string to print that string out,
Mm-hmm.
right?
Yep.
PST stir. So that's the main use for that. The
How about the double app at
the double at is like a special version.
of it?
Have you ever actually used this, Whisker?
No, I don't believe so.
I haven't either. Have you?
I've not used it in any of my code directly, but I have used it in I've had other people's code that I've modified that has it in it.
I see.
It's a little it's got its special case uses.
Okay.
So what it's doing is it's the offset to that symbol in memory, depending on the context. If you're in PASM, it means one thing, and if you're in spin, it's the address in hub memory for it, right? Which is, it's kind of like confusing that it's the same thing as at.
Yeah.
Sort of on the surface, it sounds like it's the same thing,
Mm-hmm.
but it's not, because it's the offset. Let me just make sure I'm saying the right thing.
Sure.
So it's the offset from the current object's program base address. So it's a more complicated thing of if you have multiple, like when you include multiple programs in the object section,
Mm-hmm.
it has that factors in as well, and it's like it's a little bit more advanced usage of it.
Well, how about
it's kind
this?
of hard for me to explain.
That's fine.
I
I imagine that I'm not gonna really ever use it that often, I guess. But
Yeah.
what programs do you remember? Did you see them?
You see it in PASM programs because it's when they're trying to access data in hub memory offset from object that called them and set their address and stuff like that.
Huh.
It's I'm not doing a very good job of it.
So it's more of a
okay.
relative pointer.
Basically. Even the manual, it calls it, object address plus symbol, right? And that doesn't quite really
Explain.
cover it correctly, in my opinion. And it returns the value of a symbol following it plus the current object's program base address, right? So it's like the offset to a variable plus the base address of the object's program. So it's not.
Maybe
it's
this
rel-
is
So
useful for passing the actual pointers for things that are
Within.
controlled by other cogs. Would this be useful for that?
something like that. I mean, just reading the manual again, the operator is useful creating a table of offset addresses, and then at runtime, using those offsets to reference the absolute runtime addresses they represent.
Maybe it's
So
like
if you have a DAT section with strings in it, right?
mm-hmm.
Like in the example on page 173.
You can access those specific strings.
No, and then, well, yes, but then you have another DAT section which has a table of the single addresses of each of those strings,
Aha. I see.
So it's
right?
so that's what I'm
And
saying.
then,
It's like because the
It
at
allows you to do
symbol,
things like a string array.
just the at symbol takes you to the beginning of an array, but the at symbol can take you to a specific string within that array.
right, so, well, sort of, but so one key piece of the interesting thing is that a single at is the compile time offset address,
Okay.
and the double at is the runtime address,
That's
the absolute
handy.
address. And so the difference is just when the object compiles, it has an address in memory in the hub, right? And then, but it's relative to itself. With the add, it gives you the actual absolute hub address, if
Okay.
that makes sense.
Sure.
And you need that for accessing the actual memory from PASM code for sure, because you don't know where the actual object that initialized you is at in hub memory unless you get it told to you. This is like a you know a hard for me to explain because, like I said, I don't really use it, and I probably should. And some of the listeners are probably going, "But it's so useful for this or that or the other thing." And I'm like, "Well, I do. Like I said before, I tend to do more PASM and less bin."
Right.
And in some of these cases where they might use it,
Let us know. Just put it
I
in the
would just have
comments.
done it today.
Put it
Yeah,
in the comments, and then we
but
can go over that.
even though I'm supposed to be the expert, there are some things I don't know very well.
That's okay.
And
We're all learning. We are all learning. I'm fine. I mean, I'm fine with it. Like, I mean, I kind of get sort of what it is, so I'm all good.
I mean, and obviously the manual in page 173 and 174 goes through an example, which is pretty straightforward. But even just reading that, it's still
a little hazy.
It's a little hazy just because it's one of these things where it's more trying to think of a real usage for it other than some contrived thing.
Well, being able to use it to create an array of strings is very, very handy. So
yeah.
I like that.
I like that, but I mean, you could just do the array of strings another way too. I mean, there's lots of different ways of doing stuff. That's one of the things about programming that you learn. There's usually more than one way to do anything.
I like the way they did it in the manual with a DAT section with a bunch of addresses put in there.
Right.
Roy doesn't really use the DAT section for that kind of stuff. So, yeah.
For me, the DAT section is where the PASM goes.
Which is, by the way, a little frustrating. I've been trying to figure out my GPS module. And like pretty much all the code that I've been able to find is in PASM. Like most of it's in PASM. And so I'm kind of like, well, I don't even know how to analyze this to try to like either make it by myself or what have you. So far I can only get latitude, longitude. I can't get the speed or heading or altitude or anything like that. But hopefully one day soon. One day.
Well, it's one of these things where I believe they do that because they're trying to do, something that is a little more complicated to do in spin and relatively easy to do in PASM. So they probably are doing it that way because of that.
Fair enough.
When it comes to doing a lot of string parsing and manipulating, that's a little easier to do in
In
PASM,
PASM?
I think. And that's what you're doing with the GPS module.
Sure. Well, I mean, like, yeah, I just had to find the information. We'll have to
Yeah.
go through it.
We will
Yep.
eventually, I'm sure.
Yep. Now, did we want to go into binary operators then?
Well, we got about 5 minutes. We could start.
Yep. Okay.
The first couple are pretty easy.
Yeah.
Yep.
So equals. Why is it equals and equals?
So there's well, the binary operators is just showing you the two forms, and if you notice, most of them have an alternate form which has the extra equal attached onto it
Uh-huh.
down the column, and it's because you can do, for all the binary operators, you can do just x equals y or x plus y, or you could do plus equals, and it will assign as well as doing the addition.
Right.
So anyway, let's just go with the first one, right? So a single equals without the colon in front of it is assignment in the constant section.
She's
Right.
going to like a lot of these, actually.
Because normally you
Yeah.
can't do equals equals. Equals equals is in like the functions.
Well, equals is comparison. It's saying is equal.
Right. Yeah. Right.
Right.
Just like we were talking about that, the knots, that has a lot to do with comparisons.
Yeah.
Equals. That's a comparison thing.
Yeah.
Right.
Okay.
All right. So this is an assignment thing, putting one thing into another thing.
Right.
Right.
So
Rather
x,
than
x
comparing two
equals
things.
wait. So wait.
So
Yeah.
the single equals, just the equal sign,
Is made in the constant. Is used for the constant
for
block.
constants. It's
Yep.
in the con block section, and it's how you assign values to your labels. My LED is on pin 1, so LED equals 1.
Right. Right.
And it's just that's just the spin syntax is for constants in the con section. You use a single equals without anything. And then the next one, colon equals, is for variable assignment, and it's in your pub and pry function blocks. Whenever you're assigning a value to a variable, the simple case, which you've done many, many times,
Mm-hmm.
x colon equals 1. And it's just putting a 1 into x. Right?
Right.
That's all that is.
Now, we got a note on last week's first spin about how, because I put like exclamation 001 colon equals 110, and
Right.
and I should have done equals equals.
Right.
So I guess for those who don't realize it, but there is a distinction between equals equals and colon equals. So
Right.
colon equals equals is more like
Comparison.
It's a comparison. It's literally is equal.
Yeah,
what that's
is literally
saying.
equal to, and then colon equals is like
Assignment.
I am setting this variable to this value.
Correct.
Like that.
Right.
Right.
And so it's just the difference is assignment versus comparison.
Normal humans get a little bit lost on this, but programmers, it's like, yeah, you definitely need both.
Right.
Yeah. Whereas I'm like, well, it's just an equal sign.
It used to just be an equal sign for you. Now it's a tool.
Right. I guess so.
That can do things.
I guess that is true. Okay, and then plus equals. I guess we can do
first of all,
plus.
there's just plus, right, which is add.
Yeah.
So you have x plus y.
Yep.
And you can put that anywhere.
Yep.
So you do x colon equals y plus z, for example.
X
Right.
colon equals y plus z. Okay, yeah.
And then the
Right.
alternative version for it is plus equals.
Which does the addition and assignment all in one.
Uh-huh.
So like as the example, say you had, x.
Let's just do x
colon-
plus y.
Well, just x colon equals x plus y is one way to write that, right?
Okay.
Because you're doing x plus y and then you're assigning it into x, right? Now you could just do that as x plus equals y.
Okay.
It's a shorthand for doing a common thing, and all of these are the shorthand of doing the operation and then assigning it into one of the two.
What?
Right, so
Okay,
the
now you said that x plus y would go into x. Why
Well,
would-
no. X plus y is just whatever the value that is x plus y
Yeah.
is going to go into the wherever you
Whatever is set.
place that.
Yeah.
So, like if you had in a open bracket x plus y close bracket,
Yeah.
then it would just whatever x plus y evaluated to, it
Yeah.
would be that pin on in a.
Okay, but you could also do
Right.
x plus equals y.
And if you do x plus equals y, then it's going to do the x plus y and assign it to
Into x.
So
Oh, I
X
see.
will have changed.
So then
Right.
those two
So
should be
for-
different. Because
Well, they are different.
well,
you
it
have a
says
plus.
plus or plus minus.
Right.
Plus equals.
So these two columns, one column is the binary operator by itself,
Yeah.
right? And the other column is the binary operator with assignment.
Okay.
So binary operators,
see.
we didn't do this at the beginning. We should have. Binary operator is an operator that has two inputs,
Okay.
right? It has the left and right values
Okay.
around the operator.
Okay.
And so you normally just have the left and right operator, left and right values going into the operator, and the operator does something with both of them, and you get a result, and the result is going into whatever is using that expression.
Okay.
And
All right.
it's
So
hopefully-
next week, I think we're going to take a little bit of time and get into a little bit more detail on what Roy's trying to bring up here. But we're
Right.
at the end of this week's show, so we can't really get into that detail
Oh
right here.
man.
So steady up and be ready for that, Addie, because we're gonna jump right in next week with some details on.
We're gonna multiply this stuff
Well, we're gonna talk about binary
and add to our
operators
knowledge.
first off.
Right.
Okay. So you can find this show every Tuesday at firstspin.tv. And thank you guys for listening.
We'll
And
see you
we'll-
guys at the Parallax Expo.
Yes, we will.
Woohoo!
Yep.
Till
We'll all be
then.
there.
Bye.
Bye.
Bye.